Hello and welcome. Today, we're going to crack open what I like to think of as humanity's greatest cookbook. But we're not making food. Nope, we're looking at the incredible, ingenious recipes we've come up with to generate energy and, well, power our entire world. Let's get started. You know, it's something we do every single day, probably without even thinking about it. But that simple little flip connects you to this massive, unbelievably complex, and frankly brilliant system of power generation. You see, behind every single switch, there's a huge grid, and at the very beginning of that grid, there's a power plant. So today, we're diving into the core recipes that turn things like fuel, or flow, or even starlight into the electricity that runs our lives. Okay, so our first and honestly most fundamental recipe is one that humanity has been perfecting for centuries. At its heart, the idea is actually pretty simple. Use heat to create steam, and then use that steam to create motion. Okay, so take a look at this. What's so cool here is just how simple the basic idea is. I mean, think about it. The furnace and boiler. They're basically just a giant, super high-pressure kettle. All you're doing is heating up water to make this incredibly powerful steam. And that steam gets funneled over to spin a turbine, which is, when you get right down to it, a really, really fancy pinwheel. So, the crucial part here is this amazing transformation of energy. We start with chemical or nuclear energy locked inside the fuel. We convert that to heat, which then becomes the kinetic energy of the steam. That steam's energy becomes the mechanical energy of the spinning turbine, and finally, that becomes electrical energy in the generator. It's like a 5-step energy chain reaction. And to make all that heat, there are really two main ingredients you can use. On one side, you've got the classic method, burning fossil fuels, like coal or gas. That's a chemical reaction. But on the other side, you have nuclear fission. This is where we're literally splitting atoms, like uranium-235, and that releases an absolutely immense amount of heat. Kind of wild, right? Two totally different processes, but at the end of the day, they're both just trying to do the exact same thing, boil water.
And speaking of nuclear, get a load of this advanced recipe. A fast breeder reactor is this fascinating design that through its process actually creates more usable fuel than it consumes. It's like baking a loaf of bread and somehow ending up with more flour than you started with. Just an incredible feat of engineering.
But what if you could skip the whole fire and steam part? Well, our next recipe does exactly that. It harnesses the raw power of flow. We're talking the kinetic energy of moving water and air to spin a turbine directly. This is just beautiful, isn't it? To grab the power of the tides, engineers build a huge dam, called a barrage, to create a basin. When the tide is high, water fills up the basin. Then, when the tide goes out, they open the gates and all that water rushes out, spinning a turbine on its way. You're literally using the planet's own heartbeat to generate electricity. And here's a really clever bit of engineering that just boosts the whole system's efficiency. So after the water goes through the turbine in a hydro plant, it enters this specially shaped pipe called a draft tube. Because of its shape, it slows the water down and creates this suction effect, which actually helps pull more water through the turbine. It's all about squeezing out every last drop of energy. Now let's talk wind power. This table breaks down the two main designs really nicely. Those big, classic propeller-style turbines you see everywhere, those are horizontal axis wind turbines, or HAWTs. They're super efficient and are the workhorses for large-scale power. Then you have the smaller, sometimes egg-beater-looking ones. Those are vertical axis, or VAWTs. They're not as efficient, but they're perfect for smaller-scale uses, like for a home or a small business. All right, our third recipe, this might be the most elegant one of all. It completely skips the turbine. No moving parts, no steam, nothing. This is all about taking the energy from our sun, 93 million miles away, and turning it straight into electricity. The secret sauce behind solar panels is something called the photovoltaic effect. Let me break it down. Basically, when particles of light, called photons, smack into a special material like silicon, they knock electrons loose. And if you can get all those loose electrons to move in the same direction, boom, you've got an electric current.
And this diagram shows exactly how it works. Sunlight hits the solar cell, right? That cell is made of two different layers of silicon, which creates something called a p-n junction. You can think of this junction as a one-way street for those electrons that got knocked loose. It forces them to flow in just one direction through the circuit, and that flow is what powers, say, a light bulb.
Now, of course, those little silicon cells are incredibly thin, super fragile. So to actually use them in the real world, you have to package them up into a protective module. They're basically sandwiched between a tough layer of glass on the front and a durable backing sheet, all held together in a sturdy frame. And this is where the real magic of solar comes in. Its scalability. A single, tiny cell, it only makes a tiny bit of power. But you wire a bunch of them together into a module, and then you connect hundreds or even thousands of those modules into a massive array, and suddenly you're powering entire cities from a field that's just soaking up sunlight. So, we've looked at the big three: fire, flow, and sunlight. But the cookbook is always expanding. So let's check out a couple of really innovative recipes that are on the menu for the future.
This is so clever. Biomass gasification takes organic stuff. We're talking wood chips, agricultural waste, you name it. And it heats it up in an environment with very little oxygen. So instead of just burning, it turns into this combustible gas called producer gas. And you can then use that gas to power a generator. It's literally a recipe for turning trash into treasure.
Okay, how about this for a mind-bending recipe? It's called OTEC. These systems use the temperature difference between the warm water on the ocean's surface and the freezing cold water way down deep. That temperature gap is enough to boil and then condense a fluid, like Freon, which in turn drives a turbine. The ocean itself becomes a gigantic solar battery powering a continuous cycle. It's just amazing. So after our tour through this incredible energy cookbook, what are the common themes? What have we really learned about how we make power?
Well, a few core ideas really pop out. First, it seems like almost everything comes down to spinning a turbine, one way or another. Second, you realize we're not creating energy, right? We're just converting it from heat or motion or light into electricity. Third, it's super clear that every single recipe has its own pros and cons, its own unique challenges. And finally, and maybe this is the most exciting part, the cookbook is never, ever finished. We're constantly dreaming up new ways to power our world.
And just to put the sheer scale of the resources we have into perspective, listen to this incredible fact. The amount of solar energy that hits just the country of India in a single minute is enough to power that entire nation for a full day. The energy is out there. The challenge is just figuring out the best recipes to capture it. And that really brings us to the final and most important question. We have this incredible cookbook of energy recipes, from the ancient to the absolute cutting edge. As we move forward, the challenge isn't just inventing new recipes. It's about choosing the right combination to create a sustainable and powerful future for every single one of us. So, what should that menu look like?